Alright, so now let's go ahead and do graphing. So we're going to graph the sine and cosine curves first. So let's start off by graphing the sine and the cosine curves by hand. So the sine curve, if you remember, and we've talked about it many different times, we're just looking at the unit circle, and the best way to do it is knowing that this sine curve is going to be periodic. Alright, so that's one of the features of the sine and cosine curve. Actually, let me write it like this. So typically what happens is that we like to write it as 0, pi over 2, pi, 3 pi over 2, 2 pi. So this is kind of coming from the unit circle. So if you remember the unit circle, we're just basically looking at the quadrantal angles. So here's 0, here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. So we're mainly looking at these corner points. So this one was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then you go back. So this is exactly what we're going to do. So now remember, the sine function is just the x value, the y values. So notice at 0 radians, the y value is 0. So that's why we start at 0. At pi over 2 radians, the y value is 1. So we're going to go up to 1. Then when we go back to pi, so we circle over to pi, the y value goes back to 0. As we circle down to 3 pi over 2, we go down to negative 1. And then as we go to 2 pi, we complete one whole circle, or one period, we get that part. So this is basically just smoothing out the graph. This is what one period of the graph looks like. Now this thing is going to repeat, because notice I can keep going after 2 pi. I can keep adding pi over 2 each time. So this guy can also look like this: negative pi over 2, negative pi, negative 3 pi over 2, and then 2 pi, negative 2 pi. So this guy can continue on. So, and it's going to be following exactly the same pattern. So you can see that this pattern is going to continue, although it looks kind of messed up already, but the pattern itself continues, and it's going to continue over. So this guy is what we call periodic. Typically when we're graphing it, we're only going to graph one period. So the only one period that we really care about is from 0 to 2 pi. So a period is when it starts repeating. So it starts repeating every 2 pi units. Okay. So now the sine curve always starts at 0, 1, 0, negative 1, 0. So do remember that part. Do know the shape of it. Okay. Now let's look at the cosine curve. The cosine curve looks very similar to it. The only thing that's different, so I'm going to still write the same thing, pi over 2. I'll write it this way now. Zero, pi over 2, pi, 3 pi over 2, 2 pi. I'm going to do the same thing on the other side. Negative pi over 2, negative pi, negative 3 pi over 2, and then 2 pi, negative 2 pi. Now, the one that I do in black is the one that I really care about. So we're going to look at this unit circle again. Now we're going to look at the x values. So it's going to go 1, 0, negative 1, 0, 1. So at 0, you're going to get 1, because the cosine is 1. Then it's going to go down to 0. Then go down to negative 1. Back up at 0, and then 1. So you can see that the cosine curve now kind of looks like this. So it's kind of, so remember the cofunction identities that we were talking about? Notice that this looks just like the sine curve, but all that I'm doing is that, imagine that I switch this pi over 2 units over, and I reflected it about the y-axis, then you'll get that. So this is just one period of the cosine curve. This is usually what we're going to be graphing. Okay, so, which is very different. This one starts at 1. This one starts at 0. And then we can just graph the rest of it also by completing the rest of the period. Okay, so this is going to go this guy, this guy, this guy and back at 1. So this guy's just going to continue on if I smooth everything out. Oops. It looks like that. So you can see that this graph is going to continue on. Again, the ones that I really want you to look at is mainly the thing that I'm going to highlight, which is basically just the black graph. So just this part. This is really what I want to be graphing. So usually I'm going to ask you for just one period. And the one that I highlighted is the one period that I really want. But just do note that this is going to continue on. This isn't just stopping at 0 to 2 pi or from negative 2 pi to 2 pi. This is going to continue on. So for both of these guys, the domain of the graph is going to be from negative infinity to positive infinity. You can plug in any x value that you want into sine and cosine. The range, notice that it's going from negative 1 all the way to 1 for both cases. This is for both. Okay, so domain and range. Now we do have a special name for how high this wave is, because these are called waves. Sine wave and cosine waves. So let me go a little down to kind of show you the key features. So some of the characteristics is that they're both periodic functions. They both have a period or completion of one cycle of 2 pi. So every 2 pi it starts repeating. The domain of each function is negative infinity to positive infinity, and the range is negative 1 to 1. The sine graph is symmetric about the origin, so it's an odd function. You can kind of see that this guy, if I were to rotate it over, okay, you will get exactly the same graph. The cosine function is an even function because it's symmetric about the y-axis. So you can see that if I were to kind of fold this over the y-axis, you can see that you get symmetry. Okay, so you can see symmetrical stuff on the cosine. Okay. So those are some of the really key characteristics. Now, here are a couple things that we got to do, because graphing it can be a little bit of a pain. So typically the sine and cosine curves can be shifted, stretched, and compressed. So it is useful to understand how they work and how we will relate them to the general form. So usually just how we have the h and the k and all that other stuff with the other functions that we had, this time we're going to label it as A, B, C, D. So typically sines and cosines can have an A, a B in front of the X, a C afterwards, and then a D. Typically, the better way to write, to be able to graph it, is if we factor out that B term. So this is super important. Okay, so one of the things that you might want to consider doing, especially when you're graphing, is to factor out the B. Factor B. And notice that factoring out this B to both terms is basically just the same thing as dividing by B to the C. So whatever C is, when I factor out the B, all I'm just really doing is just dividing by the B. Okay, this is going to be super important when we start graphing with phase shift. Okay, so let me give you some more key things. So this A that's in front of it, if I take the absolute value, is called the amplitude of the graph. Okay, so basically it tells you the height of the wave. How high is this wave from the origin up? Okay, so this guy, the amplitude will be 1, because from the midline, so the midline is halfway through the graph, from the midline to the top, how high is it? And then we call, and that's going to be called the amplitude. Okay, and we take the absolute value of it. Now, so this will be taken care of in stretching or compressing. The value of C over B is what we call the phase shift, or the horizontal displacement. So this is basically when you shift over one unit to the left or to the right. So remember when we had like x plus h or x minus h. This means that you shift left h units. This means shift right h units. That is what this C over B is. So whenever you factor it, whatever's left over, that's how much the x values are going to move over. Okay, and we call that the phase shift. Okay, so this is similar how we do horizontal shifts of parent functions. So that's something that we want to be able to take a look at. So the phase shift. All right. So the value of b determines the period of the sine. So basically this b is messing up all the x values. So it's not going to be from 0 to 2 pi anymore. It's going to be from something to something else. So the way to determine what that is to use this formula 2 pi divided by absolute value of b. That's going to give us the new period. New period. Okay. That's both of the sine and cosine function. Okay. So typically these two are just a pain to solve. Okay. This is going to take us, this is a long process right here. Long process. All right. And then finally, we got the value of d, which is basically this vertical displacement of the graph, just putting it up and down. Okay. All right. So those are just some of the key features. In the next video, what we're going to do is grab a whole bunch of these guys.